On paper, it is unstoppable. A 58-ton spear of steel and composite armor. A 125mm smoothbore cannon capable of firing APF-SDS, armor-piercing fin-stabilized discarding sabot, at velocities exceeding 1,700 meters per second. Explosive reactive armor. Active protection systems. Thermal sights. Digital fire control. The Type 99A was built to dominate peer adversaries on open plains. Designed for shock action. Designed for breakthrough. Designed for high-intensity armored warfare in the north. But here is the contradiction. What happens when the battlefield is not a frozen plain, but a river delta? What happens when the obstacle is not an enemy tank, but a bridge rated for 45 tons? The turning point is not a missile. It is a load classification sign, because physics does not negotiate. And before this ends, one uncomfortable question has to be answered. Is the most powerful tank in China's arsenal limited not by enemy fire, but by the concrete beneath it? We will come back to that. To understand the contradiction, we have to understand geography. Northern China, Inner Mongolia, Hebei, the plains facing Russia, favors heavy armor. Long sight lines. Firm ground. Rail infrastructure designed for industrial mass. In that environment, weight is protection. More steel means more survivability against 120mm NATO sabot rounds. More armor means better resistance against tandem charge anti-tank guided missiles. And the evolution reflects that logic. The Type 59 in the 1950s weighed roughly 36 tons. Simple steel armor. Basic fire control. Then came the Type 96. Around 42 to 45 tons. Improved composite armor. Modernized optics. Then the escalation. The Type 99 series pushed beyond 50 tons. Then 55. Now the Type 99A sits around 58 tons combat loaded. Each upgrade added a thicker frontal armor, a modular explosive reactive blocks, advanced thermal imaging, a digital battlefield management, an improved engine output nearing 1,500 horsepower. On a northern battlefield, that makes sense. The math is simple. If your adversary fields 60 to 70-ton Western main battle tanks, parity requires mass. Survivability scales with material density and internal spacing geometry. But China is not a single terrain. Southern provinces, Guangdong, Guangxi, Fujian, are river-cut, humid, and saturated. Rice paddies. Soft alluvial soil. Dense urban sprawl. Narrow road networks. Thousands of medium-span civilian bridges. And in any Taiwan contingency scenario, armored forces would have to move through exactly that kind of infrastructure before even approaching a port or coastal staging area. Now the geometry changes. A tank does not just weigh 58 tons. It applies dynamic load. Static weight is what a vehicle weighs sitting still. Dynamic load is what happens when it moves, brakes, turns, or crosses a span. When a 58-ton tracked vehicle climbs onto a bridge, the effective force spikes beyond static weight due to momentum and vibration. Engineers account for this with load factors that can increase stress by 20 to 30% depending on speed. A bridge rated at 50 tons does not mean safe at 50. It means that at 50 tons, under ideal distribution, within tolerance, under inspection conditions, it survives. Many rural and secondary bridges in southern China are rated far below heavy main battle tank classification. And this is not mockery. It is mathematics. Military bridge classification uses a standardized military load classification system, MLC. A tank of the Type 99 as mass would fall roughly into the MLC 60 range. Many civilian spans are below that. Even if 80% can handle the load, 20% becomes a choke point. And choke points define maneuver warfare. Now expand that problem. Rail transport. Heavy armor rarely self-deploys long distances. It rides flat cars. Rail axles have limits. Tunnels have clearance constraints. Flat car availability matters. If only a fraction of rail assets can handle 58 tons per vehicle, deployment speed slows. Slower deployment increases predictability. Predictability increases vulnerability to surveillance and long-range fires. Logistics is not a background function. It is the bloodstream of armored warfare. And this is where the contradiction begins to form. The tank was engineered for battlefield dominance. But modern war is not just about surviving a sabot round. It is about reaching the battlefield at all. On paper, the Type 99A looks like overmatch. Its 125mm gun can fire kinetic penetrators comparable to Western long-rod sabot rounds. Its fire control system integrates laser range-finding, ballistic computation, and thermal imaging. Its frontal arc protection is optimized for head-on engagement geometry. Against older tanks, it dominates. Against lighter armored vehicles, it overwhelms. Add a 1,500 horsepower engine and hydropneumatic suspension, and the power-to-weight ratio remains competitive despite the mass increase. So the argument seems clear. More armor equals more survivability. More survivability equals battlefield persistence. Persistence equals dominance. But that equation assumes one condition: unrestricted mobility. And this is where the advantage begins to fracture. Weight does not just affect bridges. It affects ground pressure. Tracked vehicles distribute weight better than wheeled vehicles, but not infinitely. Ground pressure equals weight divided by contact area. When terrain is dry and compact, that pressure is manageable. But southern China is not dry and compact. Rice paddies, coastal mudflats, and saturated delta soil reduce bearing capacity dramatically. In those conditions, the same 58 tons that protect the crew can sink the vehicle. And once immobilized, armor thickness becomes irrelevant. A stationary tank is not a fortress. It is a target. Now add urban infrastructure. Many city overpasses and secondary roads were not engineered for sustained 60-ton military traffic. Even if they survive one crossing, repeated column movement introduces fatigue stress. Steel reinforcement bends. Concrete microfractures. Operational planners must route around weak spans. Routing creates predictability. Predictability creates kill zones. This is not ridicule. It is geometry and civil engineering. Even China's own logistical planners understand this constraint. That is why not all armored units are equipped with the heaviest platform. And here is the strategic contradiction. If the unstoppable tank cannot maneuver freely in half the terrain that defines potential southern operations, is it truly the decisive instrument? Or is dominance conditional? Before we examine the adaptation, consider the doctrine question. If you were planning a southern theater advance, would you prioritize maximum protection or maximum mobility? Make your call. The contradiction forced adaptation. China did not ignore the problem. Instead of pushing the Type 99A everywhere, it introduced a different tool for a different geometry. The Type 15. Combat weight, roughly 33 to 36 tons. That is not an incremental reduction. That is nearly 40% lighter. The design philosophy flipped. Instead of maximizing frontal armor against peer-heavy tanks, the Type 15 prioritizes a high mobility in mountainous and soft terrain, a reduced ground pressure, a smaller logistical footprint, a faster rail deployment, a greater bridge compatibility. Its 105mm gun is smaller than the 125mm on the Type 99A. Its armor package is thinner. But in southern terrain, survivability is not just about thickness. It is about avoiding immobilization. This is where doctrine becomes systems integration. Heavy units remain optimized for northern plains and potential large-scale armored confrontation. Light units operate in southern and high-altitude regions. That division of labor reflects a strategic maturity, different mass profiles for different theaters. And this is critical, because warfare is not about building the single most powerful machine. It is about building the machine that can arrive, maneuver, and sustain. Numbers alone do not define dominance. Compatibility does. At this stage, the contradiction is not failure. It is specialization. But specialization carries its own trade-offs. Because if the heavy tank cannot deploy rapidly south, and the lighter tank cannot match heavy armor in a peer engagement, what happens in a scenario that demands both? Heavy units remain optimized for northern plains and potential large-scale armored confrontation. Light units operate in southern and high-altitude regions. That division of labor reflects a strategic maturity, different mass profiles for different theaters. And this is critical, because warfare is not about building the single most powerful machine. It is about building the machine that can arrive, maneuver, and sustain. Numbers alone do not define dominance. Compatibility does. At this stage, The contradiction is not failure. It is specialization. But specialization carries its own trade-offs. Because if the heavy tank cannot deploy rapidly south, and the lighter tank cannot match heavy armor in a peer engagement, what happens in a scenario that demands both? The debate around the Type 99A often collapses into mockery. That misses the real issue. This is not about bad bridges. It is about structural alignment between weapon design and operational geometry. The Type 99A was built for high-intensity, peer-on-peer armored combat. Its frontal armor geometry is optimized for head-on engagement. Sloped glacis plates increase effective thickness. Explosive reactive armor disrupts shaped charge jets. Internal spacing improves survivability against long rod penetrators. Its fire control system integrates a laser rangefinder, a wind sensor, thermal imaging, a stabilized gun platform. That combination allows accurate fire while moving, critical in modern maneuver warfare. On an open northern plain, this matters. Engagement ranges extend beyond 2,000 meters. First shot probability becomes decisive. Survivability buys time for counterfire. In that environment, 58 tons is an advantage. But now insert the southern problem back into the equation. Bridges rated below military load classification 60. Soft ground reducing bearing capacity. Narrow urban lanes restricting turning radius. Rail choke points limiting rapid mass deployment. The heavy tank's dominance becomes conditional. And here is the pivot. Modern warfare is not about the strongest unit. It is about the unit that can be concentrated at the decisive point. If deployment is delayed by infrastructure limits, armored concentration becomes predictable. Predictable concentration invites pre-planned fires. Long-range precision artillery. Loitering munitions. Anti-armor missile ambushes at fixed crossings. Even a heavily armored tank is vulnerable from the top arc. Roof armor is thinner by necessity. Top attack munitions exploit that geometry. This is not hypothetical. Precision-guided artillery and drone-corrected fire have changed armored survivability math globally. So weight must buy enough protection to justify mobility trade-offs. If it does not, the cost curve tilts. Now compare the two Chinese platforms. Type 99A, 58 tons. A maximum protection. A northern theater optimized. Type 15. 35 tons. A reduced armor. A southern and mountainous optimized. The heavier tank survives frontal hits better. The lighter tank arrives sooner and crosses more bridges. The math becomes strategic. If only 60% of infrastructure supports 58 tons, maneuver options shrink. If 90% supports 35 tons, operational flexibility expands. Flexibility complicates enemy targeting cycles. And targeting cycles are governed by sensors and fire control. Surveillance satellites, UAVs, and synthetic aperture radar track heavy formations along limited routes. The fewer route options, the easier it is to predict movement corridors. Fire control systems on the defending side calculate a route choke points, a bridge crossings, a rail offload sites, then pre-assign fires. In this context, mobility is survivability. This is where the comment, "logistics win wars," becomes structurally accurate. Not because the tank is weak, but because geometry determines influence. However, this does not mean the Type 99A is irrelevant. It means it must operate within layered doctrine. Heavy brigades for northern plains. Light and medium forces for southern terrain. Engineer units capable of rapid bridging. Combat engineering becomes decisive. Portable military bridge systems can temporarily solve civilian span limitations. But bridging under surveillance is dangerous. Bridges attract artillery, and bridging speed is limited by equipment volume. This is not a video game. No armored force, Chinese, American, or otherwise, can ignore infrastructure compatibility. Even Western 70-ton tanks face similar constraints globally. Weight buys protection. Protection costs mobility. Mobility determines concentration. Concentration determines victory. If you were structuring the force mix, would you invest more in heavy armor, or more in mobility and engineering units to support it? Your analysis. China's answer was not denial. It was diversification. The Type 15 represents acceptance that southern operations demand lighter platforms. But the adaptation does not fully eliminate tension. Because modern conflict rarely stays in one terrain category. A Taiwan contingency, for example, would involve a port seizure operations, a urban maneuver, or amphibious landing logistics, a follow-on inland movement. Amphibious transport capacity is limited. Every additional ton reduces lift efficiency. A 58-ton tank requires stronger landing craft, reinforced ramps, and greater fuel consumption per kilometer. Fuel is another constraint. Heavier tanks burn more per hour. More fuel requires more tankers. More tankers increase logistical vulnerability. Precision strike capability has made supply nodes primary targets. That reality forces combined arms integration. Heavy tanks cannot operate independently. They require air defense umbrellas, the electronic warfare protection, engineer bridge units, a rail coordination, a fuel convoy security. This is systems integration. And it reframes the contradiction. The issue is not that the Type 99A is too heavy. It is that its influence radius depends on infrastructure compatibility. If bridges, rail, and terrain support it, it is formidable. If they do not, lighter units take the lead. The Chinese solution appears to be tiered deployment. Heavy forces for regions where mass and armor are decisive. Light forces where maneuver speed dominates. That mirrors global armored doctrine trends. But here is the unresolved tension we opened with. Does infrastructure limitation cap strategic flexibility? If planners must pre-select routes that support 58 tons, operational surprise decreases. Surprise remains one of warfare's most valuable currencies. The tank itself is powerful. The constraint lies beneath it. And that distinction matters. The Type 99A is not a design failure. It is a northern war machine. In open terrain, with solid infrastructure and planned concentration, it delivers exactly what it was built for. High survivability, accurate fire on the move, heavy frontal dominance. But modern warfare is no longer defined by a single decisive tank duel on an open plain. It is defined by reach. Reach across bridges. Reach across rail networks. Reach across soft ground. Reach under satellite surveillance. The difference between a weapon that exists and a weapon that influences the battlefield is compatibility. Infrastructure is not background scenery. It is part of the weapon system. A 58-ton tank demands bridges rated above MLC 60, a reinforced rail transport, a high-bearing soil, a heavy landing craft, a sustained fuel flow. If any of those links weaken, operational tempo slows. And tempo defines modern combat. The lighter Type 15 does not match the Type 99A in raw protection. But it crosses more spans, moves through narrower routes, deploys faster by rail, consumes less fuel per kilometer. It sacrifices armor for reach. And that trade-off reflects a broader truth shaping armored warfare globally. Physics does not reward maximum mass. It rewards optimized mass. Across the world, heavy tanks are approaching infrastructure limits. Bridges built for civilian economies were not designed for sustained 60 to 70-ton armored columns. This is not uniquely Chinese. It is structural. Which leads to the strategic takeaway. Armor thickness does not define dominance. Logistical geometry does. If a tank cannot arrive unpredictably and concentrate rapidly, its battlefield superiority becomes theoretical. But if integrated properly, heavy units in compatible terrain, lighter units in restrictive terrain, engineers bridging gaps, the contradiction narrows. No modern army fields a single solution. They field layered solutions. The Type 99A is powerful. The Type 15 is adaptive. Together, they represent specialization rather than collapse. And the final lesson is broader than one platform. In the next generation of warfare, the decisive variable will not be who builds the heaviest machine. It will be who aligns machine weight with infrastructure, logistics, and deployment speed. Mass without mobility is leverage without reach. Mobility without protection is reach without endurance. The balance defines power. So here is the closing question. Is the future of armored warfare heavier and more protected, or lighter and more mobile within real-world infrastructure limits? If you analyze warfare through physics, not headlines, subscribe. This channel breaks down dominance through engineering, not hype. The laws of load-bearing concrete do not care about propaganda. And in war, concrete has a vote.